Good day again. We will be discussing circles, specifically central and inscribed angles in a given circle. Okay, so before we go to the problem solving, let's define what central and inscribed angles are. Okay, so the definition of a central angle is a central angle is an angle whose vertex is the center of the circle. So from the definition, as long as the vertex of that angle is at the center of the circle, then it is considered as a central angle. So in the given figure, angle AOB is a central angle because it is, or its vertex O is at the center of the circle. Okay, and the arc AB here is what we call the intercepted arc of the angle AOB, or the central angle AOB. Intercepted arc is an arc which is intercepted by the angle or by the given angle in a given circle. All right, so the red arc here is the intercepted arc of angle AOB. And for the measures of central angles, now the degree measure of a minor arc of a minor arc of a circle is defined to be the measure of the central angle that intercepts it. So which means that whatever the measure of the angle, or the arc here, okay, whatever the measure of this intercepted arc, the measure of the central angle intercepting this arc AB is equal to the angle here. For example, arc AB is equal to 30 degrees. Okay, that's the intercepted arc of the central angle AOB in degree measure. Then the angle measure of the central angle AOB is also 30 degrees. Okay, so that's how we, or that's one of the, or that's the definition in a given central angle. And as a consequence, the degree measure of the corresponding major arc is equal to 360 minus the measure of the minor arc. So here, so if this is 30 degrees, therefore, the remaining arc, or the major arc, is equal to 360 degrees minus the 30-degree measure, okay, which is this. And this is equal to 330 degrees. So the arc here, okay, let's change the color. Green. Okay, so the arc here is equal to 330 degrees. All right, and of course, the measure of the angle here, okay, is also 330 degrees. All right, so that's the property of a central angle, okay, and its intercepted arc. So let's solve this problem, okay, using the central angle definition and property. So we have arcs TU is equal to negative 37x plus 2, and arc UV is equal to negative 27x minus 3. Okay, so these are the two arcs given. And the angles are this, the USV and the VST. Now the red label here, or angle measure, it means that they're congruent. So this angle is congruent to this angle, okay? So by definition, and by the given property of central angle, now if this is negative 27x minus 3, this angle is also equal to negative 27x minus 3. This is 27x minus 3, right? And if this is negative 37x plus 2, this angle is also equal to negative 37x plus 2. And why is that true? Because these angles, the TSU and the USV, are both central angles, and they intercept the arc on UV for VSU and UT or TU for TSU. Okay, So these are just, or they are just equal to its intercepted arc. And since this angle is equal to this angle, therefore the angle measured here is also equal to negative 27 x minus 3. All right, so negative. And of course, since this is a central angle, therefore the RTV or VT is equal to negative 27x minus 3 as well. Okay, so we're looking for the measure of the angle VST. So we're looking for this. Now, how do we solve this? Since we know that the complete circle has the arc, okay, the complete arc or the circle itself is 360 degrees. And also we can use the measure of the angle here. Okay, so this is equivalent to one complete rotation, which is equivalent to 360 degrees. Therefore, once we add all of the angles here, the three angles, that's equivalent to 360. Similarly, once we add all of the measures of the arcs of the given circle S here, the sum of this is equal to 360 degrees as well. So let's solve that, or let's use the given to solve for the value of x and for the angle measure of the VST. Okay, so we have, okay, we can add all the angles. So that's negative 37, negative 37x plus 2 plus negative 27, sorry, negative 27x minus 3. Okay, plus there are two negative 27x minus 3 is equal to 360 degrees. Okay, so we can combine all of this. Negative 37x minus or plus negative 27x plus negative 27x, that's 91x, negative 4s. And we have negative 6 plus 2, that's negative 4 is equal to 360 degrees. And let's solve for x. So negative 91x is equal to 364 degrees. And let's divide both sides by negative 91. So x is equal to 4, right? So x is equal to 4. So we can now solve for the measure of angle VST. That's this. Okay, let's label that angle. This angle. Okay, here we go. This angle. We're looking for the measure of this angle. So the angle VST, measure of angle VST is equal to negative 27x plus or minus 3. All right, and since we already solved for the value of x, so we can substitute that here. 4 minus 3, and this is equal to, oh, this is negative, sorry, yeah, negative. So that's negative 4. This is 108 positive minus 3. So this is equal to 105 degrees, okay? So the measure of this angle is 105 degrees with the use of the definition and property of central angle, okay? And if we are asked to solve for the measure of the arcs, then we can also solve them since we have already found the value of x, all right? And okay, so let's move on to the next, okay? Now let's define an inscribed angle. Here, it says here, an inscribed angle is an angle whose vertex lies on, okay, on the circle. A while ago, central angle is an angle whose vertex lies at the center, while inscribed angle, its vertex lies on the circle, okay? And its two sides are extended chords of the circle and intersecting of the circle at two different points. So this is our inscribed angle, okay, because the vertex lies on the circle, okay? So point P is a point on the circle, and it is the vertex of the angle APB. So this is our inscribed angle, all right? And its property is that uh, arc AB is its intercepted arc, okay? So let's say this is theta. If arc AB is theta, then the inscribed angle, okay, whose intercept is arc AB, which is angle APB, is equal to theta over 2, which means that half of its intercepted arc is equal to the measure of the inscribed angle, or twice of the measure of the inscribed angle is equal to its intercepted arc. Okay, so if this is equal to uh, 60 degrees, all right, now this is equal to 120. Okay, and if this is, okay, let's change the color. If this is 100 degrees, let's say this, the measure of this arc is equal to 50. All right, again, half of the intercepted arc of the inscribed angle is the measure of the inscribed angle, or twice of the measure of the inscribed angle is equal to the measure of the intercepted arc. Okay, so that's the property of inscribed angle. So what's the difference between central and inscribed? Or let's compare. When it comes to central, its vertex is on the vertex is on the center, okay? While for the inscribed angle, the vertex is on the circle, okay? And here, whatever the measure of the angle, that's equal to the measure of the arc. This is the arc, this is the, this is the angle, and this is the arc, okay? And here, for inscribed, now, if ever the measure of the angle or inscribed angle is theta, then its arc is 2 theta. Okay? So, or if this is beta, this is equal to beta over 2, which is the measure of the inscribed angle. So that's how we compare central and inscribed angle. All right? Or simply saying, okay, let me just erase this. For you to easily see the relation, okay, or the comparison between the two angles, we have this. Let's say this is the center of the circle, and we have a central angle AB, or A, let's say this is O, AOB. Now, if this is equal to beta, of course, since it's central angle, its intercepted arc AB is equal to beta as well. All right, and since this intercepted arc AB, or the arc AB, is also the intercepted arc of the inscribed angle APB, therefore this is beta over 2. Okay, so that's how we relate or compare the relationships between the angle and the intercepted arc of the central and the inscribed angles. Okay. So now let's deal with more problems with the application of, or using the definition and properties of inscribed and central angles. So here, let's find the question mark here. Okay, this is the unknown. Now, the first thing that you need to ask yourself is what kind of angle is given? The angle BAC. Since the vertex of this angle is on the circle, therefore it is called inscribed. Okay, it is an inscribed angle. And its property, the intercepted arc is, okay, given the intercepted arc, half of this is equal to this, or twice of the angle of this, okay, the CAB is equal to the intercepted arc. So if this is 80, so half of 80, we know that angle, or the measure of angle CAB, okay, is equal to its intercepted arc BC, half. Okay, So since we're looking for the measure of the angle CAB, so the arc is 80 degrees. 80 degrees over 2 is equal to 40 degrees. So that's the measure of CAB. Or we don't use the degree measure anymore since we are using the M or the measure. Okay, so that's how we solve. Or twice of the measure of the intercepted arc is equal to the twice the measure of the inscribed angle is equal to the measure of its intercepted arc. Okay, so 40 times 2 is equal to 80. All right, now next, let's solve question number 2. And let's solve for the arc AWV. Oh, sorry. So let's use red. Okay, WV, the arc WV. And arc WV is the intercepted arc of the angle WXV, and its measure is 42 degrees. And we said that the measure of the inscribed angle WXV is equal to half of its intercepted arc, WV over 2, arc WV. All right. So we know that the measure of angle WXV is equal to 42 degrees, is equal to WV over 2, the arc. Therefore, the arc WV is equal to what? 84 degrees. Okay, so the measure of the arc WV here is 84. Okay, now let's move on to problem number 3. So given a circle where the center is here and there is an inscribed triangle BCD, where the two angles are 49 degrees and 79 degrees, while the other one is missing. And we're looking for the intercepted arc DC here, okay? So arc DC is the intercepted arc of angle DBC here. So which means once we found this angle measure, we can easily find arc DC, all right? Now, since this is a triangle, we know that the sum of the angles of the triangle is equal to 180 degrees. So that's angle B plus angle C plus angle D is equal to 180 degrees. And angle B is unknown. Angle C is equal to 70 degrees. Angle D is equal to 49 degrees, is equal to 180 degrees. Okay, we better use the white one. I think it's better to use color white here. So angle B plus, this is equal to 119, 180 degrees. All right, so angle B is equal to 180 degrees minus 119 degrees. Okay, and this is equal to what? This is equal to 61. Am I correct? Yeah, 61. Okay, 61 degrees. Angle B is equal to 61 degrees. So this is, let's change the color. This is 61 degrees. Okay, and since, oh, this is 61 degrees. Now, since this is an inscribed angle and the intercepted arc is arc DC, therefore twice of this is equal to the intercepted arc. So twice of 61 is 122. Am I right? Yeah, 122. Therefore, arc DC is 122 degrees. Okay, so I hope we got the same answer. And let's work on problem number 4 and try solving this problem before seeing the solution, okay? All right, so let's start solving. So in this problem, we're solving for angles 1 and 2 here and here. And the givens are the arc AD is 150 degrees, and arc BC is 140 degrees. And X is not at the center of the circle. Yeah, it's not at the center. Okay, and look at this. Arc BC is an intercepted arc, or it is an arc, right? And we can say that based on the given illustration or figure, arc BC is an intercepted arc of angle BAC and angle BDC. Okay, so angles BAC and BDC are inscribed angles, and they share the same intercepted arc, which is arc BC. So by the property of intercepted arc, sorry, inscribed angle, I mean, half of the intercepted arc is equal to the inscribed angle. So this is equal to 20, okay, 20 degrees. And this one is also 20 degrees. So we have already found angle 1, right? Okay, now we have already identified angle 1 and angle BAC. So we're going to solve uh, for angle 2, correct? Okay, so here, since arc AD is an intercepted arc of the inscribed angle ABD, correct? So arc ABD is an inscribed angle, correct? So we can also use the inscribed angle property, which is half of the intercepted arc of the inscribed angle is equal to the inscribed angle. So 150 divided by 2 is equal to 75 degrees, right? So we have, we can use the triangle formed where angle 2 is found. So we can use triangle BAX, this triangle, okay? So we have BAX, BAX. If this is 20, this is 75, and we're looking for this angle 2. Let's say this is theta. So as we will not be mistaken by the 2 here, okay? So we know that the sum of the angles of a triangle is equal to 180. So that's theta plus 20 degrees plus 75 degrees is equal to 180 degrees. And theta plus 95 degrees is equal to 180 degrees. And theta is equal to 180 degrees minus 95 degrees is equal to what? That's 85 degrees. So therefore, since we let angle 2 to be theta, therefore angle 2, all right, is equal to 85 degrees. Okay, so we have found already the measures of the angles 1 and 2. So I hope we got the same answer. Okay, let's move on to problem number 5. And again, try to solve this on your own, and let's see if we will get the same answer. So we're solving for x here. We're solving for the x here. And given a circle where the center is this point, and there is an inscribed quadrilateral. All right, so here, what we can say is that in a given quadrilateral, the angle KPQ is equal to 110 degrees, right? Well, this is 110, and the measure of the arc KP is 50, and PQ, arc PQ is 30x. So we need to solve for x, but how do we do it? How do we get it? And we know that KPQ is an intercepted arc of the inscribed angle KRQ. Again, excuse me, angle KRQ, all right, angle, sorry, angle KRQ okay, its intercepted arc is KPQ. And we know that half of the intercepted arc of the inscribed angle is equal to the inscribed angle, right? So this is equals the arc or the intercepted arc KPQ Q over 2, okay, is equal to the measure of the angle KRQ or the inscribed angle. However, we don't know what the value of KRQ yet, right? All right. But if we're going to analyze this, now look at this. Let's use another color. If we're going to analyze this, the other arc here, the other arc here completes the circle, the entire circle. So the blue-green color plus the red arc, okay, is equal to the complete circle, which is 360 degrees, correct? So which means, guys, that um, if this is 50, okay, if we're going to add them up, all right, this becomes 360 degrees. And if we're going to add them up, these are just equal to 180 degrees because 360 divided by 2 is 180, right? Okay, so let's say this is our y. So as we have uh, a, a simpler expression for that angle KRQ. So we know that KRQ is y and KPQ is equal to 50 plus 30x over 2. We could say this is 25 plus 15x is equal to y, correct? And since this is 110 degrees, and this is an inscribed angle as well, therefore we can identify the measure of this arc. Again, twice of the inscribed angle measure is equal to its intercepted arc. So therefore, this is equal to 220, right? And we know that, okay, we know that the complete circle is equivalent to 360 degrees. Okay, so which means that we have 220 degrees plus 50 degrees plus 30x is equal to 360 degrees. So here, this is our equation number 1. But I think we cannot use this anymore because we have this equation already, right? So let's solve that here. So this is 30x plus 270 degrees equals 360 degrees. Okay, so 30x equals 270. 360 minus 270, that's 90, correct? Degrees, which is equivalent to x is equal to 3. Okay, do you agree? Yeah, it's equal to 3. So therefore, x here is equal to 3, or this is equal to 90. All right, this arc PQ, but we're just looking for the value of x. Okay, so it's equal to 3. And there is a special property in a quadrilateral which is inscribed in a circle. Okay, when we say inscribed, all its vertices are on the circle. Okay, so let me just clear this up. Okay, and okay, again, there is a special property in a in a quadrilateral. Okay, now let's consider its opposite angles. The opposite angles of a quadrilateral are always supplementary. Okay, so they are supplementary. And if this is 110 degrees, since they are supplementary, therefore y is equal to what? 50, sorry, 70, right? 70 degrees. So that's supplementary. So which means that half of this, we already identified y. So half of the intercepted arc is equal to 70 degrees. This is what we're talking about. So therefore, y is 70 here. 70 is equal to 25 plus 15x. Okay, let's check if we will get 3 for x. So let's solve that here. So that's 15x equals 70 minus 25, that's 45, right? Okay, and divided by 15, that's 3. Okay, so we got the same answer, x is equal to 3. So which means that our that property, okay, is actually true. All right, so again, in a quadrilateral inscribed in a circle, when we say inscribed, the vertices of that quadrilateral are on the circle. Then the opposite angles of the quadrilateral are all, the two pairs of opposite angles are supplementary to one another. So this angle are supplementary and this angle are also supplementary. Okay, so once we knew what the measure of the angle of one angle here, then we can easily identify the other because they're supplementary. Okay, I hope it's clear. So let's solve item number 6. Now in the figure below, BE is a diameter. All right, BE is the diameter, so let's identify the center. And the measure of arc BC is equal to 60. And solve for the measures of BAE. BAE, here we go, BAE, and angle D. All right, so let's change the color. Okay, so now we can solve either one of them first. So let's talk about BAE. So BAE, and this one is a diameter, right? Now there is a theorem that says when when there is in a circle, okay, let me draw that. In a circle, given a triangle where the hypotenuse is the diameter, okay, again, in a circle where the hypotenuse is the diameter, then the triangle that can be formed is always a right triangle, okay? As long as that triangle is inscribed in a given circle. When you say inscribed, all the vertices are at the circle or on the circle, okay? So all of the triangles that can be formed, inscribed triangles, are all right, okay? As long as the hypotenuse is equal to, or the longest side is the diameter of the given circle. They're always right triangle, okay? So which means if this is for the diameter, then these all angles here, inscribed angles here, let's say A, B, C, D, E, F, G, H, I, whatever, okay? As long as the longest side is the hypotenuse. Now, they're uh, the arc intercepted by those angles, let me change the color. The arc intercepted by those angles is a semicircle. Okay, this is a semicircle because the endpoint or the endpoints of the arc is the endpoints of the diameter. So which means that this is 180 degrees. Why 180? Because a diameter is a central angle. Okay, and since it's a straight line, therefore it's 180 degrees. And we knew that given a central angle, its intercepted arc measure is equal to the measure of the angle. So the measure of the angle of the diameter is 180 degrees, okay, where the diameter is central angle. Okay, therefore its intercepted arc is 180 degrees as well. So since this arc is the intercepted arc of all of the right angles formed from here, okay, from angles A, B, C, D, they are all inscribed angles. Therefore, we can use the property of inscribed angle that says half of the intercepted arc uh, of the inscribed angle is equal to the inscribed angle. So since it is 180, therefore half of this is 90. That's why these are all 90 degrees. 90 degrees, 90 degrees. And other angles or triangles that can be constructed from this, okay, from this segment, okay, are all 90 degrees. That's why it's valid to say that they're all right triangles, okay? So let's go back to the problem. Again, this is a diameter and this is an inscribed triangle. So since its intercepted arc is this, which is the intercepted arc of the diameter as a central angle, therefore this is also 90. Okay, let's use another color, green. So this is 90 degrees. Let's change to red. Okay, so as it can be easily seen, so this is 90 degrees. And however, we're looking for BAE. Oh, really? So we have already found BAE. So we found this, and this is 90 degrees, right? Based on the theorem. Okay. And we're looking for angle D. Angle D is here. Okay. This is angle D. And we know that this is 180. 180 degrees. Because that's a diameter. This is a diameter, and this is a semicircle. It's an arc. Now, the measure of the intercepted arc of angle CDE is equal to the arcs CBE, right? That's the intercepted arc of the inscribed angle CDE. And we know that since CDE is an inscribed angle, therefore half of its intercepted arc is equal to the inscribed angle. And we knew that arc CBE is composed of arcs CB plus the arc BAE all over 2, right? Okay, so, and we knew that CB or arc CB is equal to 60 degrees. And arc BAE is a semicircle, or yeah, a semicircle. Therefore, it's 180 degrees. So we need to divide this by 2. 180 plus 60, that's 240, right? 240 divided by 2, that's 120 degrees. Therefore, angle CDE is equal to 120 degrees. Therefore, this is 120 degrees, 120 degrees, 120 degrees. Okay, so we have found already the angles BAE and angle D. All right, so I hope everything is clear. Here we go. So let's have problem number 7. So in problem number 7, oh, sorry. Now let's use another color. Let's use blue. Okay, we're going to find the measure of the angle NLM. NLM, so we're looking for this. But we know that its intercepted arc is 7x minus 10, right? And look at this, guys. Since, again, there is a triangle formed in a given circle and the longest side is the diameter, then again, from the given property that we discussed a while ago, this is a right triangle and this is 90 degrees, correct? Okay, since this is a diameter and this is the angle, the intercepted arc is the arc LMN. And this is a semicircle. And semicircle is just half of the entire circle, which is 360 degrees. So half of that is 180. Therefore, if we're going to add these two arcs, they're equal to 180 degrees, right? So 13x minus 10 plus 7x minus 10 is equal to 180. Why 180 degrees? Because central angle, okay? So we have central angle and a diameter at the same time, okay? So we have, let's add. So this is 20x minus 20 equals 180 degrees. And 20x is equal to 200 and x is equal to 10. Okay, so we can now solve for measure of the angle NLM. NLM. So that's okay. The measure of angle NLM is equal to NLM is equal to half of the measure of the arc MN, right? Because angle NLM is an inscribed angle and its intercepted arc is arc MN. So arc 2 is equal to 7x minus 10 over 2. Okay, and we knew that x is equal to 10, so 7 times 10, 70 minus 10, that's 60 over 2. Therefore, it's 30 degrees. Okay, so therefore, this is 30 degrees. All right, understood? Okay, and there's another way to do this actually. Now, okay, so let me try to erase this. Okay, now look at this, guys. We know that this is the intercepted arc LM is the intercepted arc of this angle. So half of this arc is equal to this, right? Half. And also this angle is half of this. Half of this is equal to this. And since this is a right triangle, we knew that the sum of two acute angles in the right triangle is equal to 90. So once we add this 2, it's equivalent to 90 degrees, correct? So let's do that here. So that's 7x minus 10 over 2 plus 13x minus 10 all over 2 is equal to 90. Equals 90. And once we simplify this, we'll have 7x minus 10 plus 13x minus 10 is equal to 180 degrees. And we just got the same equation as this, right? So this is another way to solve for this problem with the use of the inscribed angle directly. While on our first method here, we use the concept of a semicircle, okay, or the central angle, right? Okay, so anything can be used as long as we're doing it correctly and we're not violating any rules, okay? And let's work on problem number 8. I think it's the second to the last problem. Oh, third, fourth. Okay, let's do it as fast as we could. Okay, so try to find the measure of angle FGH. This angle, right? And since this is a quadrilateral, we knew, we have discussed a while ago that given a circle inscribing a quadrilateral, okay, when we say inscribing quadrilateral or a quadrilateral inscribed in a circle, its vertices are all on the, okay, or are the points on the circle. So we knew that these two angles are opposite angles of a quadrilateral. And we said that once they are opposite, these angles are supplementary, okay? So we could say that once we add them up, 38x plus 5 plus 21x minus 2. Oh, let me erase that. Oh, let's use white. So 21x minus 2 is equal to 180. Why 180? Because they are supplementary. So this becomes 59x plus 3 is equal to 180 degrees. And 59x is equal to 183. right? So divide 59, divide 59, and x is equal to what? So what is the sum of 59 is prime, right? And 3, oh, this is 183 over 59. All right, so let's try simplifying that number. Yeah, so x is equal to 183 over 59. Okay, I think I cannot simplify that anymore. Okay, so this is our value of x, but we're looking for the measure of the angle FGH. FGH. So the measure of the angle FGH is equal to FGH 21x minus 2. So that's 183 over 59 times 21 minus 2. Okay, so let's solve this. Oh, sorry, I think I got wrong here. Okay, uh, I do apologize. So, oh, this is wrong. This must be 177. Oh my, right? 177 because we're subtracting. Okay, 177. Okay, let me erase. Oh my, let me erase everything down that. That's why we got a very odd. Okay, for me, it's an odd number. Okay, a very big fraction. Okay, so let's do it again. Sorry for that. So that's 177 over 59. 59. Okay, so let's try. Oh, this is divisible by 3, right? Yeah, so this is equal to 3. Yeah, I think I'm now at peace because x is a whole number. But it doesn't really mean that everything, whenever you solve, all the number that you will always get for the value of x or any variable is always a whole number. It could be any number. It could be a fraction or a very big fraction, okay? So, okay, so therefore x is equal to 3, and we're going to solve for the measure of the arc. Oh, we're solving for the arc FGH. FGH. Now, arc FGH, sorry for that. Okay, arc FGH, so you really need to be very careful in analyzing the given and also the question. Arc FGH is this, right? And arc FGH is the intercepted arc of which inscribed angle? This, the angle A, FAH, right? So the measure of arc FGH is equal to, okay, half of this is equal to the inscribed angle FAH, right? Okay, so let's turn it to white. Okay, so we know that FAH is equal to 38x plus 5. So this is 38x plus 5. And we know that x is equal to 3. So this is 38, 3 plus 5. So this is what? 24, 114, right? 9 plus 2, 11. So plus 5. So that's 119. Okay, so the measure of angle FAH is 119. And since we're looking for FGH, therefore the measure of the arc FGH is equal to twice of the intercepted arc. That's 238. Okay, so therefore this is now our final answer. The arc FGH is equal to 238. Okay, so again, arc FGH is the intercepted arc of the inscribed angle FAH. Here, oh, here, FAH. Get it? Okay. All right. So I hope we got the same answer. And problem number 9. So we're solving for x here. Okay, let's solve for x. Now, how do we solve this? A quadrilateral with the given arc WV and VT and the inscribed angle VWVT. Okay, now, since we're solving for x, and we need this. Why? Because since this is inscribed quadrilateral, or we call it cyclic quadrilateral because it is inscribed in a circle, now these two angles are supplementary, right? And however, we don't know what the value of this inscribed angle WXT. But we know that WVT is an inscribed arc, intercepted arc of an inscribed angle WXT, correct? Again, WVT is an inscribed intercepted arc, this is an intercepted arc of the inscribed angle WXT. So for us to solve for this, WXT angle is equal to half of the arc WVT, arc 2. Okay, again, half of this arc, intercepted arc, is equal to the inscribed angle. Okay, so we have WVT is equal to 8x minus 8 plus 126 divided by 2. So this becomes 8x plus 118. Am I right? Yeah, 118 over 2. So 4x plus 59 is equal to the angle of WXT. But we know WXT and WVT are supplementary. So the measure of WXT, angle WXT plus the measure of the angle WXT WVT, VT is equal to 180 degrees because they are supplementary angles, correct? Okay, let's use y. Okay, so we know WXT is equal to 4x plus 59, and WVT is equal to 6x plus 11 is equal to 180 degrees. Okay, so let's not solve for x. 6x plus 4x, that's 10x. 10x plus 59 plus 11, that's 70, is equal to 180, right? So 10x equals 110 and x equals 11. Okay, so we found the value of x. And if you want to find some of the measures of the arcs or the angles, okay, especially the inscribed angles, then we can easily find them because of we already found the value of x. All right, so I hope we got the same answer. And I think this is second to the last. Yeah, second to the last question. Now, given a circle O with an inscribed triangle, okay, and this is a diameter, okay, and a given triangle, equilateral triangle. And also, this angle is, sorry, let me change the color. The given angle, this angle is a central angle, right? A central angle because its vertex is at the center of the circle. Now, since this is an equilateral triangle, therefore, this is 60, this is 60, and this is also 60 degrees based on the definition of or property of an equilateral triangle. Since this is an inscribed angle and this is its intercepted arc, therefore this is also 60 degrees because the intercepted arc of a central angle is equal to its measure, right? And this arc is an intercepted arc of the angle C here. So therefore, since this angle is an inscribed angle, half of this intercepted arc is equal to C. Therefore, C degrees is equal to 60 over 2, and this is equal to 30 degrees. C degrees, therefore C is equal to 30. Okay, so we found out that it's 30. Okay, I hope we got the same answer. And last question. In the figure AOB is a diameter. Here we go. Diameter, and PCQ is a tangent to the circle. So this is tangent. All right. Find PCA. PCA. So we're solving for this. Oh, let's use another color. Let's use what color? Red. Okay. So we're solving for this angle. All right. So again, since this is a diameter, AB is a diameter, and as we mentioned earlier, this is, or it forms a right triangle because its intercepted arc is a semicircle, which is half of 360, which is 180, and half of 180 is 90, right? Since this is a triangle, right triangle, these two acute angles are complementary, so therefore this is 60 degrees, correct? 60 degrees. And since we're looking for this angle, this angle, this is an intercepted, an inscribed angle as well. And its intercepted arc is AC, arc AC, right? The same as this. Therefore, this is 60 degrees because they're sharing same intercepted arc and they're both inscribed angles, all right? Or we could say, since this is 60, this is 120 degrees. Correct? Because twice of the inscribed angle is its intercepted arc, and this is also an inscribed angle, so half of this is 60 degrees. Therefore, angle PCA is 60 degrees. So we already found the measure of the angle PCA. Okay, and if you want more problems to solve, to practice on, now you can visit the Kuta software website. Okay, kutasoftware.com. Thank you, and I hope you learned something today.